All right, today we're going to be looking at our third and final installment for the new discussions we've been having on trigonometric ratios. Okay, so let's get started. Our objective for this day is the student will apply the trigonometric ratios in order to solve for missing angle measurements. Now, yesterday's math had us using these ratios in order to solve for missing side lengths. So today, as the objective states, it's going to be theta that is missing, and we will have to solve for it. That's going to involve a slightly new skill. We do not know, or I do not know at this point in time, what the date on this lesson will be. So you can copy down the objective. You can leave the date blank, and I'm sure you'll be able to fill it in as it does get a little closer in class. As always, press pause anytime you need more time to copy down a particular page, and then hit play when you're ready to move on. Okay, so last time we used angle measurements to find missing side lengths. Today we're going to be using side lengths to find unknown angle measurements. So here's a triangle that is an example of the type of problems we're going to be having. This time it is theta that is unknown, and there are two side lengths in there which we could use as we see fit. But the question today is still going to remain. Which of the rules, which of the ratios would be appropriate to pick on to try to solve a particular problem? Now, just like last time, you're going to look at the sides that you have, and you're going to select an appropriate function to go along with it. And we'll come back to that here in just 1 second, but there is a new step that is going to be involved with solving for your missing variable. Okay, so let's take a look at that new step. Okay, now we should know well by now, through our travels in mathematics and also me repeating myself over and over again, for every operation in mathematics, there is an opposite operation that undoes it. Okay, addition and subtraction, multiplication and division, squares and square roots, stuff like that. Okay, when solving equations, we frequently have to do the opposite of an operation in order to move things from one side of the equation to the other side. Okay, so if we find the need to move a trig function, okay, then we're going to have to figure out, first off, how do you separate them? We've said here the last couple of days that the trig function and its angle measurement theta belong together. Together they are a single value. So how do you split the two of them apart if they belong to each other? So basically, in plain English, what we're saying here is we're going to need to be able to move the trig function but leave theta alone. Okay, so we're going to have to know what is the opposite of these trig functions. And it's really a very simple answer. It's just one that you have never heard of before. The opposite of a trig function is what is called its arc function. Okay, so the opposite of a trig function is called its arc function. And each of these three operations have an arc function. Okay, the opposite of sine is arcsine. Okay, and it's represented typically by an exponent that looks like a little -1 power. Okay, but it is read arcsine, not sine to the -1 or any other thing like that. The opposite of cosine is arccosine, and the opposite of tangent is arctangent. And please do get the pronunciation of these functions right. They are not sin, cos, and tan. We don't pronounce things by the way their abbreviations read. We pronounce them according to the real words that they represent. Okay, so there are the three arc functions that are going to help us with moving our trig functions from one side of the equal sign to the other. And you've probably noticed them on the face of your calculator before. They are secondary functions that are directly above the buttons that they represent, the functions they represent. So arcsine is found directly above sine, arccosine is above cosine, and arctangent is above tangent. Okay, so let's have a look at this math. Once again, we're going to have to make sure that we have right triangles, because just like sine, cosine, and tangent only work in right triangles, arc sine, arc cosine, arc tangent would have no need to be used in anything other than a right triangle. Okay, so let's proceed just like we normally would. Okay, in this particular case, we have the hypotenuse and the adjacent side, but this time it is theta that is unknown. But we're still going to select the ratio the same way that we have been. What is the ratio that uses adjacent and hypotenuse? Well, think of SOHCAHTOA. The ratio that's going to do that is going to be cosine. Okay. Now, using the rule for cosine, cosine theta equals adjacent over hypotenuse, we're going to plug in what we know. This time, theta is unknown. Adjacent is 12. Hypotenuse is 19. Now, as I've said before, the cosine and the theta belong together. So in order to split them apart, we have to do the opposite of whatever is happening between them. Well, what is currently happening is cosine. Okay, so to split the cosine and the theta apart, we must do the opposite of cosine, which is arc cosine. Okay, now it's just another math operation. Okay, so same rules apply. Whatever we do to one side of a problem, we must also do to the other side of the problem. So basically, we are taking the arc cosine of both sides of the problem. Now, the math that is happening here on the left is that a trig function and its arc function are going to cancel each other out. That will leave us only with the theta, and that's what we want. Okay. Now the other side of this problem is going to be for our calculator. Okay, so we're going to go to our calculator and we're going to go, okay, calculator, what is the arc cosine of 12 over 19? And again, there's a lot of crazy math that's going on in that calculation. You're not required to understand the math, just required to be able to get an answer at this point. And in this case, you're going to get a theta measurement of 50.83 degrees, rounded off to the nearest hundredth. Okay, and there's your theta measurement. You just used two side lengths in order to calculate an angle measurement. Okay, so let's see this work again. Okay, here is a triangle. Okay, we're going to set this one up. We're going to see if we can solve it. Actually, I didn't put anything on this page, so I believe I'm going to leave it up to you. Okay, but I'll get you started, help get you started on this. Okay, you've got an unknown theta measurement, and let's see which ratio you might want to use for this problem. Okay, if you look at the two side lengths that you do know, you have opposite and adjacent. Okay, opposite and adjacent, that's going to be tangent. Okay, so we're going to end up with tangent of theta. When it comes time to split the tangent and the theta apart, you're going to use arctangent. Just use the example that we just worked as a template to help you get it done. Also, copy this problem down, and let's see if we can figure out what function needs to be used to find theta based upon the information that we are given, and see if you can work this one out also. Please get those two worked out and bring them to class with you. For those of you that have been consistently pulling the I didn't understand it, that's why I didn't do it, I'm going to now suggest to you that you might want to start coming in the mornings and asking questions. If you are understanding things on such a bad level that you cannot even work the examples after some of them have been shown to you, then you need to walk through the door in the morning and say, I need help trying to do this, not just walk to class with a blank piece of paper. Okay, so get these two worked out, and we will see you in class.